Hello, Professor Urban here. The topic for this video is engineering. What is engineering? The broad view of engineering. So let's jump right to it. And we see image out of the book initially. What do engineers do? That's what we're going to be talking about. And if I press the right button, we'll see my outline for today, for this clip. And first question is, what does the word engineering mean? I've heard it. I've heard a lot of words, and I don't know, where did they come from? What's their origin? Why do they are they the way they are? And that's called etymology. And surprise, surprise, you can look up the etymology of any word and find out it came from Latin or Greek or Sanskrit. And in this case, the word engineer has the meaning of the early meaning of create, contrive, devise. It has to do with ingenuity and inventiveness. That's what engineering is about. And if I flip over to the internet here, we can see that the word engineer from Old French and medieval Latin and so on. And those are its root meanings. So that's what you're studying to do, to be an ingenious, inventive person. And in the most overview way of engineering, we could divide it up into two general categories. One is to analyze. You approach an existing piece of equipment. I happen to have some existing pieces of equipment sitting here underneath the document camera, and you can see several generations of cell phones, and at the top a so-called a smartphone. It's really a pocket computer, but we call it a smartphone. And if you're working for a company, and the idea being that you're going to make the next generation of cell phone, you better know how the ones work now. I mean, how are you going to make it better? And you're going to learn a lot. So that is under the heading of analysis. Taking a look at something, studying it, finding out how it works. It could be a very simple circuit or very complicated. And the other side of it is design, and that's you're going the other direction. You're saying, oh, I'm going to make an object, and I want to make it work in a certain way, a design standard that I have set for it. So one is a designed object, how does it work? And the other is, I want to make an object that meets my design. Those are both engineering. And you saw already some of the smartphones that I had on my display. And each generation of smartphone was devised in order to be better than the earlier one and put it out of business, basically. And then you'd have to get the new one because it was better, and that's what engineers are trying to make things better, ideally. So you would start out by trying to understand it completely and then design a new one. And I asked myself to show the smartphones again. So there they are. And let's just take a quick peek at what we got. Here is a really old, look how thick that thing is. And that has a battery hanging off the back because it took a lot of power to run this phone. This had a little antenna thing sticking out of the top because it wasn't doing a good job of staying in contact. And it's small, so to have a chance to have some space for a keyboard and a space for display, it was made with a hinge that you had to open it up. All right, I don't know which one of these came first. Here's another one. It has a little display on the front. The other one doesn't, so this must be newer. Who knows? And it's certainly thinner. That's always good. And it has the same idea that you have to open it up. There's a little screen on the top and some push buttons. And the push buttons are just numbers. So the input and output wasn't very good. Here's another one. This one doesn't have the hinge anymore. You can see it. You have to operate it through the top. It's obviously got to be a touch screen in order to do that. Here's another one very similar to that one. Then we come to the more modern, not that modern, but we come to the more modern one. And I have to tell it who I am with a fingerprint. That's pretty cool. And it opens up, and it's a little hard to see. Maybe if I turn off the light. Still a little hard. But you've seen these phones, so I don't think I need to belabor it. It's quite thin compared to the others. It's a lot smaller. You can take one of the older ones and set it on top and it's hanging off. Personally, I like that. I have a little bigger area that I can have a chance to see what's on there if it's real small. So those are generations in the design, and working as an engineer, one of the things you will do, almost for sure, is to be upgrading, doing things better. And why? Partly, you'll be able to do it because there will be new integrated circuits and there will be new Wi-Fi. I'm going to notice today that G5 is coming in, G3 is history, maybe I need a new phone and such like. Okay, that's fine. It's called progress and development. And you, as an engineer, will have to master knowledge in the brain, understanding, comprehending. How do you look at a problem? How do you model it? How do you think about it? And then the other thing that you have to do as an engineer is the know-how, the working with your hands, so to speak, the ability to actually fabricate a thing. Your end product isn't your idea. Your end product is an object. Almost always, not necessarily, but frequently that's it. So it has to translate from the idea to the physical world, and so that's very important to recognize that you're going to do that. I happen to like both of those things very much. I'm in the right business, and I hope you are too, and that you will figure out which corner of it is most attractive. And I'll say it's hard to know, and you may change gears several times. I certainly have. So I wouldn't sweat that too much. Find an area that you like and go after that. And what do I mean? Well, there's a lot of specialties because engineering is just too wide, too big. There's all sorts of different categories in engineering, and it's just no one person that can know them all. It's hard for a person to know the majority of what is even in one of the specialties. So that's just a factor of progress. And I've got a partial list here that I can show you quickly, I hope, because I opened it already. And there is a list, and it's a little small, from the U.S. Bureau of Labor Statistics, no less. And they're listing out all kinds of different occupational things. Here are management occupations and legal occupations and on and on. Well, we should go down and take a quick look at engineering, don't you think? It's not alphabetical, unfortunately. So education, arts, healthcare, building. I think it's following. Well, look at them all. Engineering is certainly here. It's after architecture. Fair enough. I can see why people would think about those things at the same time. And now we've navigated to this page, and we see aerospace, agricultural, bioengineering, chemical engineering, civil engineers, and so on. And if you click on any one of those, let's click on electrical, and it's a pretty good long list. And then it says all other. So let's take a quick look at electrical. And if I do that, hopefully something will happen that's good. And you start to see specialties in electrical engineering. My goodness, there are some specialties. Except computer, I don't know what that means. And it tells you a little bit about what each of those areas is. Cool. So there are many specialties, and you will have a chance to learn in one, and maybe you'll work in that, and maybe you won't, because engineers work in teams, and the teams have people with a variety of specialties, and there's a blurring of the lines once you get into the idea of having a job and working. So another thing that I want to mention, so it has a lot of areas, and in order to help the engineer stay up to speed, it's not just engineering where this is a problem. Things are changing all the time. New information is being found. New devices are being invented. What you would use to build something is completely different than you would use even 5 years ago in most cases. So how do you stay on top of all that? And the answer is you go to school for the rest of your life and you never, no, that's not it. After you get out of school, then you will become a member of one or more professional societies in the area of the interest where you are working. And I just happen to bring up a list of them that are in the United States. And here they are. And these are professional associations based in the United States. And you can see a pretty long list, and I don't know if it's comprehensive. Acoustical Society of America, American Ceramic Society, American Bladesmith, I don't even know what that is. Library Association, you can guess at that. Bar Association, you certainly know what that is, has to do with law. And these are broad categories here of professional associations. And now we can look in the subcategories. Oh my goodness. Well, it's a long and a good and an interesting career you're looking at in engineering. And to stay up, you will need to be part of these organizations. They're not expensive. They send you things in the mail. They have conferences to help you stay on top of your craft. And that was the general list. Now we're to the engineering lists. And yeah, I already gave money. I'm not going to give it over and over. So here's a list of the countries, and each country has its list of engineering associations, etc. We're under Americas, United States. Let's click on that. And I don't know how to get rid of that. Yes, I do. There it goes. And now you can see specific societies for engineering that are more narrow a little bit. Society for Engineering Education and so on. Society of Mechanical Engineers, Civil Engineers. Eta Kappa Nu, that's an honorary. I happen to belong to several of these organizations. Tau Beta Pi, or Pi Tau Sigma, I don't know what that is. So there are a lot of societies within it, and electrical and electronic engineers should be on here. Here it is. Institute of Electrical and Electronics, I'm a member of that. And if you click it, you can start to look at what it is. IEEE, 400,000 members. Oh my goodness, unbelievable. And don't you dare say IEEE or something. They tell you right here, it's called IEEE. If you don't say that, it means you don't know what you're doing. I hate to say. So, employment. What about employment situations for engineers? Well, engineers work in every kind of situation. In offices, in laboratories, ships, manufacturing, plants, government labs. All throughout society, there's jobs for engineers, and the locations of those jobs are going to be far and wide, depending on what it is you're going to do. And how about an employer? Who's going to employ you as an engineer? Who's going to be writing your check? The answer is you might start your own operation and be self-employed, and the person writing your check is a client. That's being done. That's a common thing to do. My uncle did that. Effectively self-employed. There's industry jobs. You can work for a company like Boeing or Intel. Some of those companies' jobs are fantastic. And by the way, typically they'll pick you up as a fresh out graduate in engineering and take you on to a master's program, pay for that, pay you to take it. So they're getting a better employee for a fairly small cost, and you can expect that. Government. There are laboratories and government agencies. Oak Ridge National Laboratories, a fantastic place. Sandia National Laboratories. Those are interesting places to work. I know people at a lot of those places. Businesses, companies. It turns out last time I looked, the largest number of engineers working for any single employer in the state of Florida was, drum roll, take a guess, probably wrong. The answer is Disney. Disney has more engineers working for it than Harris Semiconductor or any of the other very strongly engineering-oriented companies. And what's going on in Disney? Animatronics, keeping the rides alive, electronics, communications, software. There's a lot of engineering opportunities at Disney. I think it would kind of be cool to work for Disney. There's about 1.6 million engineering jobs out there. So, yeah, it isn't easy. Getting a degree in engineering isn't easy. Working in engineering isn't easy. But you learn it and become comfortable with it, and it's fun and interesting work. I mean, I had a friend that worked at a company in Utah that was developing explosives, and they would do the theory, and then they would go out in the field in a far safe place and blow things up. I can just imagine him coming home at night. Oh, honey, how was your day? Oh, great. We blew up 2 bridges in a building, and it worked pretty well, but we got to make it better. That was a job. That was his job. There's people working on sending spacecraft to Mars. It's very wide and varied, very interesting jobs available, and I think it's not easy to get started and get going, but you get paid well too. So you'll get the rewards if you stick it out. You're going to have interesting and well-paying work, almost for sure. If you don't, you change to another company. There's 1.6 million jobs out there. That means that they're cycling around and moving around. People are retiring and people are entering all the time. So it's quite a fluid situation. Now let's move on to a topic that, when I first saw that in our book that I'm relying on here as a text, I was a little like not real sure where they were going with that topic, actually. But it's very important, and there's a subtle aspect to it. And the basic idea is that in engineering, society depends on us for their safety. People jump in airplanes all the time, and they do it having confidence that that plane has been engineered correctly and it's been assembled correctly. I had a student who went into quality control at Boeing, and her job was to make sure that all of the components that went into that airplane were working correctly, so that when people got in there and trusted their lives to it, well, I won't talk about the 737. Sometimes things can happen, and that's a good example of why we have to talk about this topic. So let me, so at first it sounds simple. You just do the right thing, fine. But what are the dimensions of ethics? You have ethical responsibilities to yourself, to your family, to the organization that employs you, to any organization that you are interacting with, to society, to mankind. And it's inevitable that those interests will come into conflict from time to time. A perfect example is insider trading. Now, I'll tell you briefly about what that is. It turns out that insider trading means a person who works for a company buying and selling stock in that company. And if a person does that because they have special knowledge, insider knowledge about the company, then it's not fair to everybody else that doesn't happen to have that insider knowledge. It's illegal, and people have been punished severely for breaking that regulation. Now, where does that run into a conflict? Let's say you work for Intel, and you know that Intel's coming out with a new product in a month, and it's probably going to make the stock value go up. And your mother and brother and neighbor and cousin and uncle all could make money if they would buy that stock. And all you have to do is tell them, oh, hey, just buy Intel and it's going to go up. It's illegal to do that. So your responsibility to your family and your friends is trumped by your responsibility to conduct yourself in a legal way, and insider trading is illegal. So, and there's been some very high profile cases in that. Martha Stewart is just one example if you want to see what sorts of things can happen to a person. She got hauled in on insider trading and wasn't honest in the courtroom, I guess. I don't know. I don't want to be misquoting things. So how do you solve it when there are several different competing interests? And the answer is, well, the book has a really nice, some different techniques that you can employ. So I will switch over to that book and navigate to that with any luck. And I'll go down through the pages here. I'll just mention a few things. Here's a short list of what the engineering jobs are. I gave you the long list off the internet. What do engineers do? Well, analyze and design, right? We already said that. A lot of words here, no pictures. Where did they work? We already talked about that too. I want to get to the ethical part. Oh, I should make a quick mention of engineering and technology. Engineering, a degree in engineering is an education. You learn to do A, B, C, and Y, and then when you go to work, you do X, L, and theta. If you go to work and learn about technology, and this is absolutely not a criticism of tech, we have to have fantastic technologists, okay? But if you go to school in technology, in general, you learn A, B, C, and D, and then you go do A, B, C, and D. It could be installing internet service in homes. There's no design work almost, but you have to do it right. As far as I'm concerned, I hate to say, but many professions are technology. I don't want to get myself in trouble on that. What makes a good engineer? Well, duh. And how to get success as a student? Read that over. You have to do your work. That comes to that. It's not a spectator sport. You're going to get your hands dirty. You have to not just think about, but actually do things. And here's some examples of that. And I'm hoping that I will very soon run into the ethics business, and there it is. We've talked a little bit about that. You've got professional and personal ethics, and they can bump heads. And there's a code of ethics. Read that on your own. And ethical situations can come up. And the book has one way of helping us to sort of navigate that kind of problem. And the way to do that is one way. Certainly talking to the company lawyer is not a bad idea. If you think there's an ethical issue, I think I would certainly run right in there and talk to them and get some guidance about where do I stand here. I don't want to do something wrong for me. I don't want to do something wrong for the company. I don't want to do something wrong for society. So we have a chance to kind of lay it out in a grid, which shows up a little nicer on the next there. So here are the sorts of things that you can do. Let me make it a little bigger. Oh, I think I have a bigger symbol right here. That is not what I wanted. I think it's probably hard to see this. I'll say zoom right here. There we go. It's bigger, but it's like a little bit off the side. So here are some of the kinds of things that can be done across the top when there is a possible ethical situation coming up. You've got to take this very seriously. If we had unethical engineers, it would be a disaster for humanity. So what can you do? That's across the top. You can go along with the decision. This is in case you don't agree with the decision or you think there's something wrong about something that's being done at your company. Or you could appeal to higher management. Go to talk to your boss and say, hey, this is being done and it's not good and I should let you know. You can quit your job. Well, how does that fix the problem, right? It gets you out of the hot seat, but it doesn't. You write your state representative. Well, maybe. I mean, if it's something that is bad and it could hurt people, might not be a bad idea. Or call a newspaper reporter, crazy as it sounds. Those options are on the table. And then across the bottom, across this is the canons. In other words, under what conditions do you do what? And you start filling this thing out. Like, for example, you're supposed to avoid deceptive acts. Duh. You don't want to get me started here, but you can't do things wrong in engineering. And what if you're making heart pacemakers? Enough said, right? You have to be honorable and all these things. And then fill in this grid after a while and start to score it. You'll start to see, okay, the company ethics is more important than mine, or maybe I weigh it more heavily. It's a trouble that you're going to see from time to time as an engineer. Hopefully not very often, but if you do, you've really got to come down on the right side of that. So it's inevitable that now and again there will be some conflict in ethics with those different organizations, and also not being sure. I mean, I worry about the Challenger accident, that there were engineers that said we shouldn't launch on such a cold day. I actually remember that day. I was in Miami and it was a very cold day, and they are north of here. And I thought to myself, wow, with all that low temperature, something is going to contract in a different way than it would in a normal Florida day. And it seemed dangerous to me. And I don't know that I had a premonition about it. It was an engineering perspective that I had. So let us review what we have done. And if I press the right button here, I'll go back. We talked about what does engineering mean? And on the way I told you about etymology of words, which enriches you if you see a word and you want to know where it came from. What do engineers do? They analyze and they design. Here's an example. We looked at some smartphones. That's just a handy example. You've probably got one in your pocket or nearby. And to do that sort of work, you have to master a knowledge base, a fairly significant knowledge base. And you have to know how. That is, how to get something made. It's so broad, engineering as a whole, that it's broken into many specialties and subspecialties. And that's what happens when you get a broad field. And so I showed you places where you could look up some of the lists of things, of sub-areas in engineering that you could do yourself, work in yourself, or that you'll come in contact with. And We talked about professional societies and engineering societies. For sure, just make up your mind right now, you're going to have at least one of them, and they offer these to students at very low rates. We'll talk later about that. Where are you going to work? All over the place. And who's your employer going to be? You're going to self-employ, or you're going to work for a company. It could be industrial, it could be business-oriented, it could be government. I mean, I think about the engineers that work for Amazon and in the delivery of products. What an amazing example of logistics they have, that they can get things to you in no time flat from all over the place, all sorts of different products. The study of engineering is not easy, but it's not overwhelming. We have 1.6 million out there working. I have seen many students go through my class, get their degree, graduate, and get a great job and move on down the road. And maybe the job works better and pays better because it's hard. Hey, that's probably true. And society depends on us to be ethical. And we depend on it and our family and so on. And they can collide sometimes. And there's ways of starting to resolve those things. And if it's truly conflicting to you, you need to go talk to somebody about it. So that is the end. I hope you had a chance to learn some things now. Don't forget, you can start and stop. You can review it. You can go back and look at a segment. That's the nice thing about having it in video form. Maybe it's a little too much to swallow the whole clip, start to finish in one sitting. Fine, cut it into 2 sittings or 3 sittings. It's under your control. I salute you.